Good morning, Year 5. I hope you're well. Today is lesson 6 of our series of decimal lessons, and today we're going to continue our lessons on understanding thousands. Yesterday we began to consider the value of thousands. We used deans to represent whole numbers, tenths, hundreds and thousands, and we're able to use the deans to create numbers up to 3 decimal places. We also began to consider the relative size of a thousandth in terms of against a whole number. It was 1,000th. It was one part of 1,000 parts that made up a whole number. For today, our counters that we'll be using are our place value counters. You will recognize this one because we've used these before. These are our ones. This is a whole number. We have our tenths, we have our hundredths, and then we have our thousandths. All of these counters will be used in these columns to represent these numbers. Just as an extra step, just so you know, if you were to make one whole, you would actually need 10 of these counters. If we had 10 of these counters, it would equal one whole. And if I had 10 of these counters, I would have 10 tenths, and 10 tenths is equal to one whole, and I could actually exchange it over for one whole. But also, just to let you know of interest, one of these counters, one of these is equal to 10 hundredths. So I could actually say one of these is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 10 times larger than one of these, so it would take 10 of these to make one of these. So if I had 10 hundredths, I could exchange it for 1/10. But then again, if I had just 1/100th, that's actually equal to 10 thousandths. So I would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if I had 10 thousandths, I could exchange those for 1/100th. And if I had 10 hundredths, I could exchange it for 1/10. And if I had 10 tenths, I could exchange it for one whole. So there is a relationship linking all of these counters and all of these place value allocations for our thousandths, hundredths, tenths, and our whole numbers. And then the same relationship would continue as we kept going up into our tens, our hundreds, our thousands, etc. So for today's lesson, I just want us to concentrate on how to actually make numbers using our place value counters. So it's nice and straightforward. You'll be drawing this in your book. Obviously, you guys would use rulers. Give yourself plenty of space in your books when answering the questions. So first of all, if I was going to create a number such as, let's go for 0.234. Well, if we look at this number, this is a decimal, and we need to represent it here using our place value counter. Well, we see straight away we have no ones, so that we don't need to have anything in here. We can then have the decimal point, so it's going to go after the decimal point. I'm actually going to put a 0 in there so we can see it. But now I need to represent the next part. So the next column is our tenths, and we have 2 tenths. So we would have 2 of these counters in here. Then we have 3 hundredths, so we need 3 of these counters. And last but not least, we have our thousandths, and we have 4 thousandths. And we would represent it using place value counters like this. So if you saw this number represented in its place value, you could say I have 0 ones, I have my decimal point, I have 2 tenths, 3 hundredths, 4 thousandths, so this will be equal to 0.234, which is represented here as a decimal. Okay, so let's have a look at another example. So this time I'm going to go for 1.305. So this time I do have some ones, so I'd represent it. The 1, I now have my decimal point, because the rest of the numbers come after the decimal point. I do have 3 tenths, so I can represent that using my tenths counters. I have no hundredths, so I do not need to place anything in here. And I have 5 thousandths, and I would place 5 of these in here. And I've now used my place value counters to represent this decimal number. So I have 1.305 as a decimal. Okay, I'm going to do another example here, but like the way you're going to do it in your book, I'm going to draw it this time just so I can do it the same as you. So instead of using my place value counters, I'm just going to draw this. I've got 4 ones, and remember the column represents the ones. You can label if you want, 1, 2, 3, 4. If you want, you can put 1 in there if it helps you, but because it's in the ones column, you assume therefore each one has a value of 1. I have no tenths, but I must remember to put my decimal point in because we are now after the decimal point. 0 tenths, 0 hundredths, and then 9 thousandths. 1, 2, 3, 4, 5, 6, 7, 8, 9. So here I have represented using place value counters 4.009. And there's a decimal 4.009. This just helps you get a better understanding of how numbers are written when we're using decimals and how to translate between the two. Often you will get sometimes problems and they will just show you this representation using the decimal, using the place value counters, and you have to translate this from place value counters into a decimal or vice versa from a decimal into place value counters. Okay, I'd like you guys now to have a go at trying to solve one. So you'd be pausing the video here, and I want you to draw a place value grid, ones, tenths, hundreds, thousandths with your decimal point, and I want you to solve this by drawing in your books this problem 6.345. Draw that in your books using your place value counters. Pause the video here. Okay, so hopefully when you were creating this, you first of all looked at the number before the decimal point, which is 6. So you know you have 6 whole numbers. I'm using my counters again, just so you see the visual representation. You'll be drawing them in your books. You have your decimal point, so it's 6 point something. I have 3 tenths. 1, 2, 3. I have 4 hundredths. 1, 2, 3, 4. And last but not least, I'm on my thousandths, and I have 5 of those. 1, 2, 3, 4, 5. Oops, excuse me, 5. So I have visually represented this number 6.345, 6.345. Well done if you got that right today. For today you have some questions at the end of the class page on the sheet. You also have some challenge questions which are on the PowerPoint. Best of luck today, guys. See you tomorrow.